So hi guys, in today's session we will learn about sound. So first let's learn about the type of sound and how sound are produced. First thing, by mechanical waves. We all know that what is mechanical energy. Okay. For example, if we want to travel from one place to another, we have to walk. So similarly, for sound to travel, it uses mechanical energy. So those kind of waves which uses the mechanical energy are called mechanical waves. Okay, and there are two types of waves. That is longitudinal waves and transverse wave, which we will be discussing in detail. Okay, so this is just a schematic diagram of how the waves captured from the orbit. So longitudinal waves was a transverse wave. So we can all see that, for example, ECG signals in the medical equipments. So we can see that there is some graphs going on, the pulses. So the upper part is called the crest, the lower part is called the trough, and wavelength is nothing but from one crest to another crest. So that is called our wavelength, and amplitude is nothing but our height respectively. But for example, let's take a spring. If you take a spring and if you try to expand, that is called a refraction, and if we just leave it, it comes back to its original position. That is called compression. And longitudinal waves consist of both compressions and rarefactions, whereas transverse wave consists of trough and crest respectively. So for example, the examples in longitudinal waves are what? Sound waves in air, solid and liquid. The other one is only on the surface of the liquid. For example, if you throw a stone on the lake, so we can see that stone will jump like this and go. So there is nothing but a transverse wave respectively. And coming to the light wave. So there is one guy called D. Broglie. Okay, he told that light is an electromagnetic wave. Okay, which means light can be both particle nature and wave nature. Particle nature and wave nature. So which means light can be as a particle as well as a wave, but whereas sound is only of a wave nature respectively. Okay, so that is the major difference between sound and light. And one more thing in the speed. We all know that speed of light is what? 3 into 10 power 8 meter per second. But what about sound, which is very less, 330 meter per second. So this is the sound which you are hearing, and this is the wavelength of the thing. And what are the major factors affecting the characteristics of sound? So first one is what? The pitch of the sound, the loudness of the sound, then sound tone quality. Then the major thing is reflection, transmission and diffraction. Diffraction is nothing but the bending of light or bending of the medium. It can be light, sound or anything. And what is transmission? For example, from loudspeaker, it is transmitting sound waves. It is called transmission. Reflection, bouncing back of the waves. Okay, so that is, anyway, we will learn in detail about reflection. It is nothing but an echo. We will learn in detail. Okay, reflection of sound waves. So reflection of sound wave is nothing but what? I told you, echo. So that we will be learning in detail. So mainly, where are we using this reflection of the sound? In loudspeaker, and doctors use in stethoscope respectively, and the guys who cannot hear, the hearing aid. So echo is nothing but, if you are going to let's take a mountain or a very high altitude surface, and if you are just saying something very loud or something, so something which repeats what we are saying, that is nothing but our echo. So which means if we hear our own reflection of sound, that is called echo. So which everyone knows the thing. Okay. So this I am not gonna tell you what is the uses of everything, that you can read. And coming to damped vibration, forced vibration, free vibration. The most difficult thing about this is damped vibration. So which means even if we learn the definition, end of the class, most of us won't understand what is damped vibration. So that I will give you a small example. Let's take this thing. Okay. So we can see that the crest and trough are almost same. But what about this thing? Here something is okay, here very low, here very high. So which means the waves are not in a proper manner, which means the waves keep on decreasing or increasing. This is called damped vibration, and this is called undamped. Undamped in the sense not affected. Undamped in the sense not affected. So one is damped, other is undamped. Okay, so that is the thing. Resonance is nothing but if I apply an external force, okay, and the external force is a frequency, and if that frequency matches with the frequency of an object, okay, so that is called resonance. So in a very simple word, let us take the bell in a temple. So if I am just applying my external force to ring that temple bell, it resonates, which means there will be some kind of a wave kind of thing that we can feel. So which means that the more the force, the more the wave we will feel. So it is nothing but when I am applying an external force to an object, it has a frequency, and if that frequency matches with the natural frequency of that object, it is called resonant frequency. So mainly used in radio and TV receivers, but now we are not using any resonance. This is all on the 1990s, not even in 2000. Okay, so now we use set-top box and all those things, so which does not need any resonance. Intensity, loudness and intensity. So there is a difference in loudness. If someone is shouting, so that is called loudness. But what is intensity? The amount of work you are doing. For example, if you are working hard for the coming preparatory exam by waking up in the morning or in studying after going home from the classes. So that is nothing but the intensity that you put out to work. Okay. But loudness, if I am just by hearting something, okay, loudness is a measure of the response of the ear to the sound. So that is nothing but it will create some loudness, but end of the day, after 1 or 2 months or after the exam, we won't even remember these things. So there is a major difference between loudness and intensity. So intensity is nothing but what? When there is much more into it. So when we are into that particular thing, that is called the intensity. Loudness, for example. So now I am speaking in a tone. Suppose someone is going outside the class and I want to call him up and he is almost outside the class itself. So I will just increase my loudness. So which means the loudness depends on the distance and also on the amount of tone I am using. That tone is called amplitude. Amplitude is nothing but what? This height. This is nothing but our amplitude respectively. Amplitude respectively. And if more the distance, then the less sound we hear. For example, if I say something here, in America we cannot hear. That is the meaning of this particular meaning. Okay. The loudness, pitch and quality. So quality is nothing but our intensity. The pitch is nothing but what? The tone which I use. Okay. If it is a lower tone, then it will have longer wavelength. But if it is a higher tone, it will have shorter wavelength. Again, loudness, less the amplitude, lower loud. Higher the amplitude, higher sound. Okay. So again, coming to the last slide. So this is the thing. A pure note. Noise is nothing but, what is noise? This is undamped vibration. What is a damped vibration? This is our damped. So this damped vibration is also called what? Our noise. So if we compare and study, then it will be much more easier for us to know the things. Fine. So this is the thing. Pure sound and this particular thing. Yeah.